Good evening, all. Good evening, all. You're welcome to today's lecture. Today we'll take a look at physics. Okay, we are still on the topic motion. This is our second contact on this topic, motion. No, this should be third contact or so. Anyway, let's continue. Our reference books for today are: number one is New School Physics for Senior Secondary School by M.W. Anyakoha, PhD, 2016 edition, and Prep 50 Physics, UTME past questions. So where did we stop in our last physics class? Where did we stop? Come see, where did we stop? I say in our last physics class, where did we stop? Okay, yeah, I can make a velocity time graph. Okay, in our last class, we defined, I think this should be our third contact. We defined these parameters: velocity, speed, acceleration, displacement, distance, and we moved over to what? The velocity time graph, okay? Then we also talked about instantaneous what? Velocity, okay? Instantaneous velocity. And I think that's where we'll stop. We did a calculation, right? On that, okay? Okay, I say that today we'll do more calculations. I think that's what we said. The calculation there was taken from this textbook. So I said that today we do calculations on the velocity, acceleration, velocity time graph, and the displacement time what? Graph. Are you okay? You don't look as if you're okay. What's that? You're feeling sleepy? Okay, sorry. All right, so let's see what we see. Let's look for questions from this from the JAM question papers. Let's see what we can make out of this. Okay. Motion. Okay, let's see. Let's look at this question. Okay, this question is from JAM 1993 JAM Physics. Question 3. The question says, okay, so when you are done copying, like I'll give you like 3 minutes to solve this question. What did I say about the distance, total distance covered? Huh? What did I say about the total distance covered in a velocity time graph? I'm asking you. You were in class that day, so tell me, what did I say about the total distance? Half what? No. What did I say about it? Solve now. So, what did I say about the area under a curve? I mean the total distance covered. I said something about it. You are there in this class, so don't keep quiet, please. You are there, so tell us. Tell us what I said about the area. No? What I said about the total the distance covered. You want to calculate the distance covered in a velocity time graph. Check your note fast. I made the general statements. For a uniform motion, I made a statement on that. I gave you people 3 minutes, so 1 hour 30 minutes have gone. So let's see who can solve it. This thing is what you should know, even though you are not in the class. So it's a simple thing to do. It's SS1 topic. True or false? True. So tell me, what's the answer? Okay. What's the answer? See, how is he? This one, how is he? Tell me how is A. How do you get A? Can I ask you a question? What did I say about the inverse time graph? How you determine what represents the distance covered? Remember, we said that in inverse time graph, uniformly that shows the uniform motion. That the acceleration is the what? The slope. Remember, the slope of the what? The graph is the what? The acceleration. Remember, we said that. Now, so what is the distance covered? What represent the distance covered? So from this diagram here, please, sorry, this thing did not terminate here, please. This thing cut in between 40 and 50. Sorry about that. From here, it cuts between what? 40 and somewhere here. Okay? Somewhere here, in between 40 and 50. Okay? So what did I say about the the distance cover? The area under the curve. Simple. Area under the what? Curve. Depending on the shape formed by the what? By the curve or the graph. Okay? Look at this one now. What is the name of this shape? Trapezium. So the area of the shape formed under the curve gives you the area, the distance covered. Okay? Are we together? Good. So just it's simple. Just find the area of this what? Trapezium. If you like, you can also, how many, if you break this trapezium down, how many shapes are you going to get here? Look up. If you break down this trapezium, how many shapes are you going to get? What are they? So two triangles, right? And one rectangle. So if you don't want to use the area of trapezium, you can get the area of this triangle, keep it. Get the area of this rectangle, keep it. Get the area of this triangle here, and add up everything. It will give you the same value, which is the area under this what? Curve. Okay? So that is exactly what you did. I don't know what you're doing now. You did not say it well now. You don't mention area. You are just talking about shape. For someone that was in the class, I don't think it's a good thing. Okay, please, after class, please go through your work. Try on your own to solve more questions based on the things we did in the class. It's very important. Don't leave it in your book. Go through it, fine. Try to solve on your own. Solve more questions on that topic. It will help you to do what? To retain it. So now let's solve. So okay. Now let me not solve. I give you the clue, right? Now what is the answer? Solve it now. What is the area of this trapezium? And tell me the answer fast. If you don't know the area of trapezium now, I don't know what you are doing. For real. All right, fast, no time. I want you to solve this yourself. That's why I'm doing this. I would have solved it, but I want you to solve it yourself. Because this is not teaching. We are just solving questions based on what you have already done in this class. So I shouldn't be spoon feeding you. Oh yeah. What is the area of trapezium? Yes. What is area of a triangle? Area of a triangle is what? Length times width. Triangle. What are you saying? Is that what?
Area
Is what?
1/2 bracket A plus B bracket H.
Okay, that H is what?
Height.
That A is what?
Area.
A is what? B is what are you saying? She said that area of a trapezium is. She said that area of a trapezium is area of what? Is what? Is what? This what I should put multiplication here. It doesn't matter. It's something. Okay. So the operation here is multiplication. The operation here is what? Multiplication. Okay. All right. So now from this, I am seriously. I'm not happy that I'm doing this in here again. I'm not happy. Seriously. It shows. It doesn't show that we are picking distance. Please, I shouldn't be doing this all the time. It's not good. Now look up, please. Area of trapezium. Half A plus B times what? Height. From this diagram now, from this diagram, look up, please, look up. Look, see what I'm doing, please. Look up. From the diagram now, A is this side, okay? B is what? A is from here to where? Here, okay? B is from here to where? Here. All together. A is from here to here. B is from here to where? Here. The height, this is the H. This is the height, okay? Okay. If you watch, the height corresponds to velocity, which is 10 what? Meter per second. True of us? Trace it now. The height corresponds to what? 10 meter per second. Because this axis is for what? Velocity. All together. Now, while this side and this side, they have the same unit. They correspond, if you trace them, they correspond to time. Okay? That's why you can add them, because they have the same unit. This is short side, shorter side, longer side. This A, if you trace from here, this is 40, right? This is what? 10. So A is what? 30 what? Seconds. Yeah, look at it now. Here is 40 seconds. Here is 10 seconds. What is between two of them is what? Just simply do 40 seconds minus what? 10 seconds. Is what? 30 seconds. So A is what? A is what? B is what? Tell me what B is. B is what? Look at the diagram. B is what? Times it off. What are you saying? B is what? Look at the diagram now. Tell me what B is. How is it 50? I said that, okay, where did B stop in the diagram? 50, how?
Okay. 45.
45 now, is it not between, you stop at where? So B is what? 25, how? How is it 25? Where did it start? 0. So how is it 25? So there's something that started from 0 and stopped at 45. How is it 25? Is what? Is what? 45 now, we simply do 45 minus 0 is what? 45. So B is what? 45 what? Seconds. H is what? 10 what? 10 what? 10 what? 10 what? Good. 10 meter per seconds. So we can now substitute. We can now do what? I follow you. So from here now, area of this trapezium is now what? Half bracket what? 30 seconds plus what? 45 what? Seconds. Times what? 10 meter per what? Second. Are we together? So if you add this up now, 30 seconds plus 45 seconds is what? Is what? Is what? 75 seconds. So if we, this will not give us what? Let's open the bracket and multiply out. Half times what? This plus this is what? 75, right? 75 what? Seconds times what? 10 meter per what? Seconds. Is it clear? This is 75, not 25. This is what? 75. Is it clear? So let's now multiply. If you multiply 75, of course, this seconds is this is per seconds, right? So to cancel this what? seconds. True or false? So this will cancel this second. So we are left with what? Meters, which is the distance with distance is measured in what? Meter. So let us now deal with the numbers now. 75 times 10 is what? 750, right? This covered during the acceleration and retardation. And there are specific periods, acceleration period and retardation period. But I solved total distance covered. Work. What are these? What? Total distance covered. Right? Right? Which is 375, right? But the question says, that's what I saw. What we total distance on the morning. Yes, from the beginning of the day to the end of the day. But this one is talking about this is about doing violation with periods. Look at this now. There's acceleration period. The first triangle, right? Why the second triangle represent what? With a period, right? Let's find the ellipse and it up and see. From your right. Let's the first anyway, we can let me just do what I want to do now. The diagram is like this, right? It's like this. Here, so look at it costs between 5 and 10, 15 and 10. Okay, let's see. Here is what? 10, 20. Do you know? Good. 20, 30, 40, 50. Velocity. Meter per second. Here was. Here is what? 10. Here is what? 5. Don't know. I will take it to be. I will take that one. Let you can do. Which one? Is it okay?
What we have here.
Okay. Thank you for that. Thank you for the version. Thank you. Right? It's okay, right?
Yes.
Wow. I like this one. This is confusing. During the acceleration periods and the retardation period. Listen now. The total distance covered in the whole journey is from here to here, right? Which with the figure I gave you, right? Now let's assume we are solving a question now, okay? Let's see what the answer will get. I modify that the diagram a bit. Here I put this to be 10, but following what is I place 10 here. I place this in here. Let's see whether the option we get. Now, this is acceleration because the from here accelerated. Are you please look up this place, please. It accelerated from 0 here to this point, right? And becomes what? Constant. True or false? When you get to these points, instead of what? Retarding until the velocity becomes what? 0. Okay? Now, that is this triangle here is the distance covered in what? Acceleration what? Period, right? While the area of this triangle is acceleration is the distance covered in what? Retardation what? Period. So let's do this and let's calculate this and add them and see what we get. Okay? Here is what? Remember, area of the plan is what? Is what? Half base times what? Height. Two of us. Which is now equal to half. The base is what? Here to here is what? 10 what? 10 seconds. So times what? 10 seconds. Times height. Times the height. The height is what? The height is times the height. Here the height, right? Right? Here the height. And if you extrapolate it, it will come between what? I'm not following the diagram exactly. Look at it. There it is here. You may be wrong. But let me follow it. You know, this, let me follow it and see what. In the first one, I modified it by myself. I placed it to be on 10 here. Okay? I shoot it to the 10. But let me follow this and see what we get. So here is now half. If you trace it from here to here, we have what? Between 10 and 15, what do we have? Between 10 and 15, what should we have here? Huh? No. Between 10 and 15. I thought it's 6.5. I can see it's 2.5. Are you following? Okay. Times 12 at what? 5, right? Okay? How to get if we do it this way, the answer this is 12 what? Second. 10 times 125, right? 10 times 12 is what? 125. 125 divided by 2 is what? 125 divided by 2 is what? 62.5. 62.5, right? 62.5 meters. This is for this acceleration, right? Maybe for what? Retardation. Here, from here to here is what? Between 10 and 15 is what? Is what? 0.5. So remember here, the same what? The same what? Half base times what? Height. The same what? Half base times what? Height. Here now, 1/2 times. The base is now what? From here is what? 45, right? Right? 45. 40 to 45 is what? 5 what? 5 seconds. So times 5 what? Seconds. Times height. The height here is also equal to what? 12.5, right? 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 12.5. What's the answer? 12.5 times 5. Remember that 12.5 times 10 here is 125, right? Right? So 12.5 times 5 should give you 62.5. Huh? 62.5. 6.5, right? Ivory. 5 seconds times, this is 12 meters per what? 5 seconds times 12 meters per second is what? 60. Because once you cancel seconds, 1.5. That's it. By what's the answer? This should give us 93.75 meters. 3.75 meters. You may not see the. Is it among the? Huh? It's not. Look at this diagram here. Look at it. This diagram. Cut here. This is my issue. No, I used 10 before here. Should I use 10 to see what I will get? This is not the down back. This may actually be. I am not with the real passport paper. This is printed one from it. So let's put them here, okay? No, I'll not leave it. I'll just use 10 there and see what it will give us, okay? So if you put here now, what will it give us? X and 10 is now what? 100, right? Divided by 2 is what? 50. So let's put 50 by the side, okay? 50 watts meter. Let's come here. If you put 10 here, it's still what? 10, right? 10 times 5 is what? 50, right? Right? Divided by 2 is what? So add 25 here. What's the answer? So the thing is actually at 10. You know, I've seen errors like this. Maybe I'm trying to draw it again here, they will mistakenly place it where it should not be. So please, this thing is at 10. So that initial diagram was correct, okay? Two of us, let's use that initial diagram, let's ignore this one. But the only correction I want us to make here is that they ask us to do what? To find what? This can cover our session plan what? If you want and solved to the end of the what? Journey. Okay? So, do you know what I want us to do now? You can go to that question, that initial question. Am I communicating? You can go to that initial question. You can make it A and B. Okay? You can make A and B. You can put A part of the question to B. Total distance covered during the entire what? Journey. Okay? Do you understand what I'm saying? Because that thing we saw them was total distance covered the entire journey. Have you seen have you noticed that 25 is there, 5 is here. So let us now I don't know what I'm saying. First the diagram will be total distance covered throughout the journey, okay? Distance covered at the and the what? Iteration. So the answer to the first one is 35, then the answer to the second one is 75. Okay? Let's do that. I like this question. This question, it brought out a lot of things. Right? Technical. I like it. This is the type of question that I like. So this is also a lesson. Please, if you enter JAMB, if you want to, you see how I just rush and answering for the what? Entire distance covered from the beginning of the journey to the end of the journey. I didn't look at the question properly. It was after solving the question that I started looking at it and now noticed acceleration period and what? Retardation period. So we are knowing it is not enough. You should be very careful in solving. Any question? If you have any question, please feel free to ask. Any question? Okay. It can come in any shape. Yes. But because of the nature of this shape describes the motion, it starts from here, get to the point, became constant, and come down. So that's why it normally take this shape. But it can take any shape. This uniformly accelerated motion and uniformly retarded what? Motion, okay? Sorry. Okay, now let's solve another one. It seems they like this this okay. Are you done? Okay, you are done, right? Okay, I want to write another question again that is related to the more traits. You don't get as notification. Okay, so what you can do about that? Thank you for liking the live. Only last born, you're welcome. Okay, shall we?
Yeah.
All right, so let's look at another question. This one is from Jam Physics, 1999. Oh, okay. I was about writing question for 1999 question 7 before I remember that I made a mistake in the one I saw. Okay, now let me write down. Okay, for this let me now write down this question. Okay, the question says. Okay, option A. attempt this question. Attempt this question. Feel free to attempt this question. Drop your answer on the comment section. So let's see how far. Oh yeah, I need 2 minutes to do that. It's simple. It's not difficult. Try it, okay? We have 3 minutes. So let's see how far we can go. Two minutes more. The question is not difficult. It's a simple question. Very simple question. Very simple question. Kairalo, you're welcome. Nepo, you're welcome. You can solve and drop your answer on the comment section. A minute to go. You don't ask to find the distance. You ask to find the acceleration and retardation. This thing you're finding the area under that is the distance. Question says find the what? Find the what? Acceleration and what? Retardation. Okay? For you to be able to do that, you go back to the definition of acceleration. Go back to the definition of retardation. From there, you can come up. Go back to what you did on acceleration and retardation before you can solve the question. Jude, let me see what you are doing. Okay? So, the question The dark blue shows the velocity time graph of its acceleration respectively are this is the velocity time graph. Now, this from rest is what? Right? So, the velocity became what? 50 seconds. How did this 50 seconds? Probably the rest started mounted or whatever. He started or retarded until it becomes what? Zero. At this point, velocity is what? Zero. At time 90, zero. Now, we are asked to calculate the okay, is there any confusion here? Is there any confusion here? Okay. This is for here we solve for the what? Acceleration, okay? Which is 4 meters per second. This is for what? This retardation or what? Deceleration. Change in velocity, the same change in velocity, but here now, the V2 is now what? Zero. V2 here is now what? Zero, because the vehicle has come to rest, okay? While V1 is what? 80 meters per second, because it started retiring from 80 meters per second, okay? Then the T2 is what is it called again? It's 90 seconds, because finally it come to rest at 90 seconds, while it started coming to rest from 50 seconds. So this now gives us minus 2 meters per second square. This minus indicates what? Retardation, negative what? Acceleration. Are we together? Negative what? Acceleration. Retardation, negative acceleration. So the answer is actually what? C, which is what? 4.0 meters per second square for what? Acceleration, and 2.0 meters per second square for what? Retardation. Any quick question? You can't cancel now. Remember this thing is like meter over seconds over seconds. You can't cancel. This one come up. Law of indices. You can't cancel it out. Okay, sorry, the mic went off. Sorry, we have actually concluded for the day. I'll just make an announcement. We have actually concluded for the day. I need to know when the mic went off. Okay, let me just say one or two things. We are trying to. Our live streaming was disconnected when I saw this part. So just virtually calculating, we calculated the acceleration here and what the retardation here. It's the same formula. The acceleration and retardation. Minus what? 80 meter per seconds. Okay, so that's what we did, and at the end, we now got 80 meter per second divided by what? 40 seconds, and that will give us minus 80 meter per second. Indicates what? Retardation. That's all. And here, this one is straightforward. You just okay. So V2 is here for the acceleration. V2 is what? 80 meter per second, because it's accelerating at what? From 0 meter per second until you get to 80 meter per second. That's why V2 is what? 80 meter per second, and V1 initial velocity is what? 0 meter per second. The time before the acceleration, before it's accelerating, so that time T1 is 0.